Now let's talk a little bit about tangential relationships, and I'm not talking about people. All right, so what we're talking about here is that if we've got a wheel like this, okay, if there's some distance along this wheel, or it could be the distance that the wheel rolls, right? Okay, that's the linear thing on the edge of the wheel. Or we could be talking about the tangential. Maybe the wheel's rolling and there's a tangential velocity like this. We've already talked about that, right? Or the wheel's accelerating. There's a tangential acceleration. So these are the tangential things. Right, that's what's happening at the edge of the wheel. Okay, and what we want to do is relate these to angular quantities, and these are actually fairly simple, right? All we do is we just multiply. This one is given to us, by the way. That's in the data packet, right? So the tangential velocity is the angular velocity times the radius. That's our radius. Okay, and then the angular acceleration is just the angular acceleration times the radius, and wow, that's interesting. How to do that? Okay, it's being really fritzy fresh, right? And then the distance along the edge is the angle times the radius, right? So all you do is you take the angular quantity, multiply by the radius, and you have the linear quantity at the edge. Okay. Okay, that's at the edge. And then just be very, very careful. These guys, all of these guys, okay, they all must be in radians, either radians or for omega radians per second, or for alpha radians per second squared. Okay? Just be sure. You can't do it with RPMs. You can't do it with rotations per second. It's got to be radians. All right, good enough. Let's go to the next one here, right? So here's an example, and this is in the, if you have that little note guide, I'll put it on the website there. You can see it. You can fill this in. It's on the note guide, right? So a certain gyro spinner has an angular velocity of 10,000 RPMs and a diameter of 1.1 centimeters. What is the velocity? Well, the velocity is going to be, V is just going to be omega r, okay? But there's two things that are going to trip us up, right? One is diameter. Just always check. Let me just say that when I did all the problems in the book last year, I'd always mess up diameter and radius. So just stop and take a look. Did I give you the diameter or did I give you the radius? And then, of course, we got centimeters too, right? Okay, so let's figure that out. R is 1.1 centimeters over 2. So that's 0.55 centimeters, which is 0.0055 meters. Is that right? I think that's right, yeah. It'd be 5.5 millimeters, right, wouldn't it? And millimeters start here. So yeah, I'm going to stick with that, right? So that's my R, right? And then omega, we got to figure out omega, right? It's 10,000 RPM, but that's just not going to do it because we have to have radians per second. So 10,000 rev per minute multiplied by 2 pi rad per rev, right? And then multiply by 1 minute over 60 seconds. And again, the revs go away, the minutes cancel, we end up with radians per second, right? So 10,000 times 2 times pi divided by, divided by 60. All right, here we go. Let's see if that works. 1,047.2. Okay, so now all I have to do is I just go V is 1,047.2 rad per second times 0.0055 meters. Now notice we're going to get meter radians per second. But remember, the radian really isn't a unit. It's meters per meter. It's a pure number. It's actually the ratio of the arc length on the edge of a wheel and the radius, okay? Theta is actually S over R, where R is the radius, S is this curvy distance on the edge of the wheel. So it's a pure number. It's really a fraction of a full circle is what it is, I guess. Is that right? Yeah. Fraction of the full circumference, or fraction of the radius. No, fraction of the radius. That's what it is. Okay, good enough. Okay, so I'm going to multiply that by 0.0055. And I get 5.759 meters per second, right? Meters per second. And that's pretty fast. That's like 13 miles an hour. Not too fast. All right. In the next few videos, we'll do some of these problems.